Hello, hello. Today I have Vils, which I don't know what that means. Vils by Powerfully Compling, and I'm excited to try it. So we've got normal 6 by 6 Sudoku rules applying here. So instead of a 9 by 9 grid, we have a 6 by 6 grid, but otherwise the rules are the same. We only have 6 digits. So digits 1 to 6 will appear once each in every row, every column, and every, I guess, 2 by 3 box. This also has doublers, so maybe we can talk about the other rules for a second before we talk about doublers. So modular lines, these green lines are modular. So every length 3 section of this line will have one digit or one value each from values that have a 0 remainder when divided by 3, a 1 remainder when divided by 3, and a 2 remainder when divided by 3. And one of the things that we will, I'm sure, note at some point in this puzzle is that if you know, let's say I knew the remainder of this value here, then if I go 3 spaces away, that's going to have the same remainder. That's kind of one of the secrets of modular lines, and that's because, suppose that weren't true, suppose this were some other remainder, then what would happen is that this has some remainder and these two are the other two, and one of these two would be orange, because orange is not purple. And so now these 3 would definitely not have all 3 because they wouldn't have purple, right? So if these have one of each, then neither of these are purple. If these also have one of each, it has to be purple. So, so that's how those modular lines work. We have x's and v's. So values on x's sum to 10, and values on v's sum to 5. And now you might, if we didn't know about doublers, we'd say, well, this puzzle's broken because with the digits 1 to 6, the only way to make 10 is 4 and 6 using 2 different digits. And so I'd have 4 and 6 here. I'd also have 4 and 6 here, but then I have 4 and 6 in 3 different cells in this row, and that's going to break. But never fear, we have doublers in this puzzle. And so doublers are going to double the value of a particular digit for the purposes of these modular lines or for these x's and v's. So that, yeah, those are all the rules. And the doubler specifically, I need 1 each in each row, 1 in each column, 1 in each box, and I also need each digit to have been doubled once. So I might have, the 1 is doubled here, the 2 is doubled here, 3 is here, 4, 5, 6, etc. Obviously, it doesn't have to go in that exact configuration, but each digit is gonna appear once in a doubler. And those are all the rules. So where do we start? So, I mean, this line is interesting to me because it covers the whole box. And if it covers the whole box, I mean, without doublers, that would be totally fine, right? So actually, maybe we should think about how each digit, when it's doubled, how that changes what modular group it's in. So, right, we have the digits. I'm just going to put down here to think about them. I've got the 6 digits, 1, 2, 3, 4, 5, 6. And if I think about modular groups, these are one group. These I'll call the 2 group, and these I'll call the 0 group. Now, if I double 1, that's 2. It's going to put me in the blue group. If I double 4, that's going to get 8. That also puts me in the blue group, right? 2, 5, and 8 are all in the 2 group. They all have a remainder of 2 and divided by 3. So if I double a green number, it turns into the blue kind. And similarly, if I double the blue kind, it's going to turn into the green kind. So 2 turns into 4, which is green. 5 turns into 10, which if I kept going 1, 4, 7, 10, 10 is in the green group as well. So blue and green kind of switch places when they're doubled, whereas 3 and 6, they stay pink, right? 3 would double to 6, which obviously is pink. 6 doubles to 12, which also has a remainder of 0. So blue and green are going to switch places, 3 and 6 are not. So in this box where I had the digits 1 to 6, if I try to double 1, 2, 4, or 5, then what's going to happen is I'm going to have too many digits of the same type in this box, right? So because of this modular line, right? These 2 are the same type. In fact, I'm going to get rid of these colors. And now these 2 are the same type from the reason the trick I showed earlier. These 2 are the same type, and these 2 are the same type. I don't know what those types are, but there you have it. And if I tried to say double the 1, then that 1, I mean, I don't know where the 1 would be, but it would turn one of these digits into a different group. And that would mean I would have 3 digits of the same group, which isn't going to fit in this orientation, in this pattern I've drawn here. And if I double 2, that's going to turn into something in the 1 group. That also is going to have a problem. Only by doubling a 3 or a 6 is that going to be okay. So in this box, either a 3 or a 6 is doubled. And that actually doesn't seem that helpful now that I see it. So let's think about this line. This line is interesting because I actually use different colors here because I don't know how these correspond to these. Well, I guess I know this isn't pink, so this is either blue or green. But this, whatever it is, shows up as value. Let's call those yellow here. And this one, because it's 3 away, 1, 2, 3. This one also 1, 2, 3 away is here. So these two are the same value. Let's call those orange. Sorry, I'm sure there's some color, but I'm going to get rid of these soon, hopefully. So, because I think what I'm actually going to want to do is shade for doublers. So in this setup, oh, and more importantly, this is a type that's distinct from either of these. Yeah, this is actually the important part, which is, where does purple go in the box? Purple goes in the box either in one of those two spots or one of those two spots. The digit, not necessarily the value. Clearly not the value, actually, because this value can't repeat less than 3 away from itself on the modular line. So this digit has to appear as either an orange or a yellow digit somewhere, which means it's either doubled here or it's doubled in one of these places. But either way, that means these aren't doubled. So I'm actually going to do this. I'm going to delete these, and I'm going to start highlighting in, let's go with pink. No, it's too bright. In green, digits that are, or cells that are definitely not doubled. Which means in this, and these two are different types. And that means that one of these is doubled. And so the thing that's doubled can't be 3 or 6, because if the thing that's doubled is 3 or 6, what will happen is, let's say these were 3 and 6. One of them's doubled. They're in the same group. Now these two have to be in the same group, either the 1 group or the 2 group, doesn't matter which. Now these two are in the same group and neither's doubled, which breaks this modular line. So here I can't have 3 or 6 doubled. I need to have something in the 1 group or the 2 group doubled. And that will, let's say this were the doubled cell. When I find doubled cells, maybe I'll label those pink. And let's say this is in the 1 group. Then this cell 3 away would have to be in the 2 group. And now what are these 2 digits? Well, they can't be in the 1 and 2 group. They can't be both in the 1 group because one in the 1 group is taken. They can't both be in the 2 group because one in the 2 group is taken. So they have to be from the 3-6 group. Now again, that's assuming this is one of these two is the doubler. If one of these two is the doubler, then these are 3 and 6. If one of these two is the doubler, then 3 and 6 are in those two. By the way, 3 and 6 aren't here. So these are from 1, 2, 4, and 5. There's 1 from each group. So one of these digits is 1 or 4, and the other digit is 2 or 5. How does that help me? And this digit, by appearing in here in a different group, is also not 3 or 6. So this is 1, 2, 4, 5, and it's not 5, because 5 can't possibly work on this 10 line. Even if I double it, it's 10 immediately. If I don't double it, I need another 5, but I can't put another digit 5 there, and I can't use another digit to multiply to 5. So it's not 5. It's not 1 either, because if it's 1, a real 1, this has to be 9, which I can't get with a doubler because it's odd. And if it's doubled, I need an 8 here, but it can't also be doubled because then I have 2 doublers in the same row. So this is either 2 or 4. If it's 2, I guess if it's 2 undoubled, it could be with a doubled 4. And if it's 2 doubled, it would go with a 6. And if it's 4 doubled, it could go with a 2. And if it's 4 undoubled, it would go with a 6. Or doubled 3, actually. Okay. Oh, but okay. I wish I had this drawn. So I just realized that, okay, so these two are in the same group by virtue of being 3 apart. And these two are in the same group by virtue of being 3 apart. So neither of these can be the 3-6 group. Because if either of these were a 3-6 pair, that would mean 3 and 6. Like if this were the 3-6 pair, then I'd get 3 and 6 up here, which would break this modular line. If this is a 3-6 pair, 3 and 6 go down here, which would also break this. So 3 and 6 are actually this one. And here, 3 can't be a natural 3, but 3 could be a doubled 3. 6 can't be doubled. So if this were a natural 3, this has to be 7, which I can't get to with a digit or a double digit. So if this is a 3, it's got to be doubled. So it's a value of 6. Oh, so I'm going to get a 2, 4 here. So, and if it's 6, it can't be doubled because I'd have 12, which is already too big. So this value is 6 regardless of whether it's doubled. Oh, which actually means the doubler here is 3. That's kind of interesting. So yeah, these aren't doubled. One of these is the doubler and it's the 3, because if this is doubled, it's the 3. If it's not doubled, it's the 6, and this is doubled and it's the 3. So whichever is the doubler here is a 3. It's kind of an interesting thing. Because remember, to make this work before, either the 3 or 6 was doubled, and now I know it's the 3. But now, and what that means, this value is 6. So this value is 4. I just don't know if it's a real 4 or a doubled 2, but I do at least get a 2-4 pair here, which I think limits this a bit, right? Because if this is 2, that's 4. This can't be a doubled 4 anymore. So it had to be 8. So it couldn't be 8. So, wait, hold on. Could this be? Oh, this could be a double 2, right? So if this can't be a natural 2, because if it's a natural 2, that's 4. This would have had to have been a doubled 4, so that breaks. So this could be a doubled 2, in which case that's 6. This can't be a doubled 4 anymore, because that would make this 2, and this would also have to be 2, because if this is a doubled 4, it can't have a doubled 1 right next to it. So either way, this is, hold on. Either way, this is a real 4. So one of these is the doubler, and none of these are doublers, and this value is 6. Let me go back and make sure that's right. That felt a little sloppy. So I have this 2-4 pair here, which means these digits are 1. Maybe I can just do 1, 3, 5, 6. This can't be 5, right? If this is a 3, it would have to be doubled. A doubled 3 would mean neither of these are doubled, but both of these have to be value 4. If this is a doubled 3. Because if this is a doubled 3, these are both value 6. So these are both doubled. These are both value 4. One of these has to be doubled. That doesn't work. So this can't be 3. This can't be a 1. So that's a 6. I think that's an easier way to think about it. And it can't be a doubled 6. So that's natural. This is a 1, 3, 5 triple, but this can't be 5 on a V. And now, since these are both value 6, one of these is doubled. So none of those are. Which means this is either value 2 or value 4, which obviously could be a 2 or a 4, or it could be a doubled 1 going with this 3. Or a doubled 2 going with this 1, actually. Okay, no, I think we already knew this wasn't 3 or 6. 6 goes in one of these spots. 6 goes in one of these spots. Oh, actually, interesting, the double digit here is a 2. So I know I have a doubled 3 in one of those spots, a doubled 2 in one of those spots. So if this is doubled, it's actually a 1. Yeah, that could work. Oh, and the 6, we said one of these is 3 and one of these is 6. So the 6 is going to go here somewhere, and the 3 is going to go here somewhere. and they're going to be offset. I wonder if there's some interplay here. Like if this is 3, that's 6. If this is 3, that's 6. So the 3 goes with the 6 somehow. If this is 6, I mean 3s and 6s are interesting because the doubler doesn't matter for the modular line. So if this is 6, this is 3 or 6. I mean, I don't know. Well, if it's 6, 3, 6, if this is 6, this is 3. So this is not 6 either way, because if this is 6, we get 6, 3, 6. Oh no, this could be 3, I guess. No, because we can't have, oh, we can't have 3 on this line because 6 is on this line. I mean, we could have a 3 here. But this set of digits is something from the 1 group, something from the 2 group, and something from the 0 group. The thing that's from the 0 group is 6. So I can't put a 3 there because doubling the 0 group doesn't change anything. So one of these is 3, so that's not. And now this starts to potentially be interesting because this has to have 1 of each group. I guess it could be doubled. Well, how does that work? Suppose I have a doubler down here. No, it's not going to work as a logical. I was hoping I could force the doubler in here, but I don't think I can. Because I could always put a doubled 3 in here somehow. But going back to this idea, like I'm wondering if I can put 1 or 5 in here. If I put, let's say I put 1 in here. This is 5. And this is 2, 3, 4. And if it's 2, 3, 4, oh, it's not, we could have the 3 doubled. And then this 1 would go with 4. Yeah, that all just seems to work. One of these is a 3. I wonder if there's some problem with this being a 3-6 pair. It's not immediately obvious to me. If this is a 3-6 pair, this is either 3 or 6, so this is going to be 3 because it can't be 6. I mean, that seems fine. Okay, what happens if this is 4? If this is 4, then the 1 is up here, and the 4 in here somewhere is doubled and goes with 2 or 5. If this is 2, it's doubled, so it's really a 4. And there's definitely a 5 up here. Oh, wait, hold on. If this is a doubled 2, there's really a 5 up here. Right, and then one of these is also... Wait, no, that doesn't work. Hold on. No, that's fine. I'd have a natural 2 and a doubled 1 or 4. I had it backwards in my head. Okay, so this is a doubled 2. The natural 2, the undoubled 2 would go one of these places. The undoubled 5 would go here. And I would have 1 or 4 doubled on one of these sides. Oh, wait. Look at this. This is not, the doubler's not over here. The doubler's over here. This is really cool. If this is a 3, it's doubled. right? But if this is the 3 goes up here, which is not doubled, because the double digit in here is in the 1 group or the 2 group. The 3 and 6 that I have labeled here are not doubled. It's whatever's, it's some other digit that's doubled. So if this is 3 and the doubler, these aren't doublers. This is the 3 which isn't doubled, and so the double digit goes here with the 6 below it. But the exact same logic, the same pattern flows from here. If this is the doubled 3, then these aren't doubled. This is the 3, and this is the double digit. So my doubler actually is in one of those 2 spots, which means it's not in either of those, and it's not in any of these. And now I do get, there's a 3 on here somewhere, but it could easily be 3, 3, 6 pair. And now the digit that's over here has to be the opposite kind, the opposite residue as one or as this digit, whatever it is. So if this is a 1, I get 2 or 5 here, doubled, and then I get a 1 or 4 here. If this is a 5, I get a 1 or 4 here, which means these are the same type. So this is either 1, 4 or 2, 5. Wait, hold on. No, did I do that wrong? This is a different type than this, but this one gets doubled. I did do it wrong. This digit gets doubled, so the double digit is the same type as this. This is a different type from this, which is the same in value as this. So this is a different type from this. So it's either 1, 2 or 4, 5. I had it exactly backwards. 1, 2 would be great because I get 3, 5 immediately. 3, 5, 4. Hold on, how's this going to work? If this is 4, 5, actually, if it's 4 or 5, 6 might be harder. If it's 4, 5, 6, 4, 5, 6 also have to go down here. And I get 4, 1 for sure, 2, 3, 5, 6. Wait, hold on. No, because this could be doubled or not. Okay, all that's wrong. All that's wrong because this could be doubled or not. That's what I missed. Hold on. In fact, the value here is 4, which means the value here is in the 2 group, which means the thing in here that gets doubled is in the 1 group. The thing that's in here that gets doubled is the 1 group. So if this is 1 and I had doubled 4 here, that would cause a problem down here because I wouldn't have a 1 or 4. So this in fact is a 5. But that doesn't tell me anything about this because it depends on whether or not it's doubled. So there's definitely a 2 and a 3 on this line with 1 or 4. This has a 1 or 4 on it. This has a 1 or 4 on it actually. So these are from 2, 3, 5. Definitely got a 3 in either 2 or 5. And now what? So what do I know is doubled? One of these is a 2. This is 1 or 4. This is 3. I bet I'm going to double a 6 here. Because if this is a 4, which it very well could be, I end up with 4, 5, 6 down here. Oh, hold on. No, so if this is 4, it's not doubled, meaning this is doubled, meaning there's no doubler here, and it's 4, 5, 6, and that's fine. And if this is a 2, then it's doubled. I need a doubler down here. But my digits are 2, 5, 6. So it's it'd be my 5 actually that gets doubled. So 6 doesn't get doubled here either way. So my doubled 6, and in fact, I have an X-wing on 6s here. My doubled 6 is in one of these two spots. What am I doubled? My doubled 5 could be here. But I think it could also be over here. Or, I mean, it could clearly be here. Wait, hold on. Those were two interesting cases that I think might have something that's the same here. If this is a doubled 2, we get 2. Oh, first of all, there's no 1 here. This is a 1-3 pair. There's no 1 here. And this can't be a doubled 2 because one of these is a doubled 2. So it's either a natural 2 or a 4, which must also be natural. So this is not doubled. And these now are a 5-6 pair. And the 6 is not doubled. Right? Hold on. I think we just showed that the 6 is not. So I think the 5 here is doubled. Hold on. If this is the doubled 2, then there's a doubler down here, but this is 2, 5, 6. And this would have to be the 2. The 5 would have to be doubled to not be the same type as the 2. So if this is a doubled 2, I get a doubled 5 here. If this is a 4, I get 4, 5, 6 here, but this is doubled. Oh. No, then I just get no doublers here. So it's not the same. Okay. I have a 1 here somewhere. Is that helpful? I don't know. The thing with these 6x6s is each step can just be really, really hard because there aren't that many of them, potentially. If this is a doubled 2, this is a real 2 with a doubled 5. Maybe I can get these 3s to conflict. So if this is, how would this conflict? So if this is, let's say this is 3. Oh no, that doesn't tell me. So maybe I have to think about it from here. If this is a doubled 2, say, then this can't be doubled. So it's a 6. So if this is a doubled 2, that's a 6, that's a 3. Oh, I think that does break. That's kind of long. If this is a doubler, that's not, so it's a 6. Which means that's a 3. So if this is a doubler, that's a 3. But if this is a doubler, then it's the 2, and that's the 4. This becomes a 4, 5, 6, 4, 1, 3. So if this is a doubler, these cells are both 3s, which doesn't work. I'm going to use it. That's a 4, undoubled. So this is my doubled 2. That's my first doubler in the board. Which does mean the 2 is here, which unfortunately does not resolve this at all, actually. But I do know I have a 5 double. So my doublers are now 2, 5, 3, 1 or 4, These aren't doubled. Which I think means my doubled 6 now has to be here. Or my double digit here is a 5. So where's my doubled 6? This is a 3. This is a 1 or a 4. Not here, not here, not here. So one of these is my doubler. I mean, I guess I knew that these weren't doubled from my X-wing on doublers. But I know it's actually the 6 here that's doubled now. So I have a doubled 2, doubled 6, doubled 5, doubled 3. I have a doubled 1 or 4 here and a doubled 1 or 4 here. Oh, this isn't a 2, which means it necessarily has a 5. And I also have a 5 here. So my 5 here is not doubled. This is going to be confusing because my 6 here is doubled. And normally I like to have corner marks for doubled things, but I don't want to put a 1 and 4 because I don't know whether it's 1 or 4 here. That's doubled. Oh, this isn't a 3 because this, so I have a 1 or 4 here that's doubled and a 1 or 4 here that's doubled, so they must be different. So this 1 or 4 doesn't appear here because it's not the doubled 1 or 4 that's here or the 6. So it must appear in this row or a column. So it's in this column, and therefore here. So that's not a 3, that is. This is 1 or 4, as is this, I suppose. And the other 1 or 4 goes here. This is not 6 then, that's 6. And this is 1 or 4. This is not 6, that's 6, which is doubled. So this is not, which means that's the 5. Get that before I get confused. This is the doubler. So that's 1 or 4. This is a 2, 3 pair. How am I going to resolve those 1, 4s actually? Maybe these, I suppose. Maybe it's this now. So this is either 1, 4 or 2, 5. Like I can probably do some markup here because this is also 1, 4 or 2, 5. And the 1 and the 4 here and the 2 here actually. So the 2, 5 either goes 2, 5 or 2, 5. And the 1, 4 either goes 1, 4 or 1, 4, which actually isn't that helpful. Okay. Yeah, of course that's not. So this digit is not doubled. So it's either, and the 5 is. So this is either the 1 group or the 0 group. If it's a 0 group, it's a 3. If it's the 1 group, it's a 4. Because 1 is here. One of these is a 5, so that's not. And so 5 in this box is here, which is a 6 here. Here we go, which is not doubled. That is. That's not. That is. That's not. That is. And the 6 is what's not doubled. Oops. So this is my 6. This is 1 or 4. This is my 5 now. This is a 3, 2, yeah. Well, no, it's not going to all resolve. I still have to somehow do the 1s and 4s. My 2, I don't know where the 2 is here. What? Okay, what am I missing now? The 6 goes a 3 up here. So this is a 2. There we go. 4. 1, 4, 3, 6 here. Oh, I knew the doubler was a 3 as well, so I could have filled that in immediately. 4. Now this is the 1, so this is the 4. This is 1, 2. And yeah, great job. Great job, me. Wow, who was that? Good job, Palfley, for this puzzle. It's really neat. I really liked how the doubler and the modular lines interacted and all these cool little geometry tricks you put in here. Very neat. Yeah, definitely quite tough for a 6x6. Anyway, thanks for sending it in, and thank you for watching, and I'll see you next time. Bye.